Imagine Greenland in the future. What would it look like? The ice sheet would probably have melted due to climate change, and the rocks and minerals would be left behind. The rocks left behind will build up, and this is called a moraine. It's an accumulation of glacial debris. We found these moraines interesting because it can tell us what content is underneath the Greenlandic ice sheet. Therefore, we ask, what impact is the melting of the Greenlandic ice sheet going to have in the future? To help us pursue this question, we also wondered, what do the moraines at Kellyville and Point 660 tell us about the content underneath the Greenlandic ice sheet?
We think that our method can help future investigations to find out what minerals are hidden underneath the Greenlandic ice sheet. We also think that the content of the moraines at Kellyville and Point 660 do origin from different locations underneath the Greenlandic ice sheet and hence contains different rocks and minerals, showing what minerals are hidden where underneath the ice sheet.
To conduct this research, we went to the moraines at Kellyville and Point 660. We marked a 1.5 times 1.5 meter square, 4 times at each moraine. From each plot, we collected 25 rocks. That's a total of 200 rocks. We brought the rocks home and identified each of them. We split them up into 4 categories: gneiss, amphibole, pegmatite, and other rocks.
Gneiss is a metamorphic rock that is common in Geomorphology. It can have different light colors and it's made of layers. It's created in high temperature and pressure. Most of the amphibolite we found has once been basalt, which later has been metamorphed and turned into the amphibolite. When a rock is being metamorphed, it is exposed to high pressure and temperature. Pegmatite is uncommon in Geomorphology. It's mixed but not in layers, volcanic igneous rock. Garnet is a mineral that's commonly mixed with metamorphic rocks like schist and amphibolite. Most of the time the garnet is red but can be in other colors too.
We also measured the striations and geomarks. Striations are made when a glacier pulls sediments underneath it and it polishes the bedrock. Geomarks are made from larger rocks that scatters across the bedrock when the glacier moves forward.
What we saw was that the glacier came from the east and moved towards the west. So now we know that the glacier came from the Greenlandic ice sheet. We also wanted to know if it was the same glacier that created the different moraines. As we see on the pie charts, there were 52% gneiss at Kellyville compared to the 18% at Point 660. Another noticeable difference is there's the double amount of amphibolite at Point 660 compared to Kellyville. We also saw that the gneiss at Point 660 contained garnets and that the lichen could be found on the rocks at Kellyville.
So, what does this mean? In conclusion, we saw that the moraines at Kellyville and Point 660 were not created by the same glacier, but by 2 different glaciers. We can also conclude that our method is usable for determining rocks and minerals underneath the Greenlandic ice sheet. Our research may be able to help the people of Kangerlussuaq in the future in terms of income and business. If the airport will be closing, a new business has to be established. With our research, we looked into an opportunity and future use of Kangerlussuaq, as minerals can be found and be accessed when the ice retreats.
Some rocks. Okay, so this is like there's feldspar in this rock.